Imagine an object coming from the depths of interstellar space, traveling for millions of years through the cosmic void until it crosses our solar system. Now imagine that this object accelerates when it should decelerate, challenging all the laws of physics that we know. Cosmic coincidence, or something much more unsettling? In 2017, we detected for the first time in human history a visitor from another star system. And what we discovered forever changed our understanding of the universe and raised questions that science still can't fully answer. Welcome to a journey through the far reaches of the cosmos, where the border between the natural and the artificial becomes dangerously thin. Today, we will explore 3 interstellar objects that crossed our solar system, each more enigmatic than the last. Get ready to meet Oumuamua, the first interstellar messenger that divided the scientific community between rational explanations and extraordinary possibilities. We'll unravel Borisov, the second visitor that behaved exactly as we expected, and finally dive into the mystery of Three-Eye Atlas, a cosmic giant so old it may have witnessed the birth of the galaxy's first stars. What you are about to discover will challenge your certainties about our place in the universe. For decades, scientists theorized about the existence of interstellar objects wandering through the galaxy, lost fragments of distant solar systems traveling eternally through the void. But theory is one thing, concrete evidence is another entirely. When we finally detected the first of these cosmic visitors in 2017, the scientific community was not prepared for what they found. Skepticism is an essential tool of science, but what happens when the data simply doesn't fit any conventional explanation? The Oumuamua case exposed an uncomfortable truth about our knowledge of the universe. There are still phenomena that challenge our most fundamental categories. Some scientists proposed elaborate natural explanations involving invisible gases and exotic compositions. Others, including respected astronomers from institutions like Harvard, dared to suggest the unthinkable. What if it wasn't natural? The resistance to considering unconventional possibilities in science is understandable. After all, extraordinary claims require extraordinary evidence. But what if the evidence is already extraordinary in itself? Ignoring anomalous data because it doesn't fit our pre-established models is just as dangerous as accepting fantastic explanations without scrutiny. The real challenge is not choosing between skepticism and credulity, but keeping an open mind enough to recognize when something genuinely new emerges from the unknown. The first messenger, Oumuamua. In October 2017, the Pan-STARRS telescope in Hawaii detected an object moving through the solar system at a staggering speed of 87 kilometers per second. The trajectory was unmistakable, a perfect hyperbola, the mathematical signature of something that came from outside and would never return. This was not a common asteroid orbiting the sun, nor a periodic comet performing its programmed cosmic dance. It was something totally different, a genuine traveler from the stars. Hawaiian astronomers gave it an appropriate name, Oumuamua, which in Hawaiian means roughly the first messenger coming from afar. And what a strange message this first emissary brought, as telescopes around the world turned to study it in the few weeks before it disappeared forever into deep space. Each new observation only deepened the mystery. The object reflected sunlight in an extraordinary way, its brightness oscillating dramatically every 7 hours, suggesting it was spinning like a cosmic lighthouse. The analysis of these light fluctuations revealed something astonishing. Oumuamua had an extremely elongated shape, with a length-to-width ratio of at least 10:1. Imagine a giant cigar flying through space, or perhaps a flattened disc like a classic science fiction flying saucer. Both shapes were possible given the observations, and both were profoundly unusual. In nature, objects tend to form in roughly spherical shapes due to gravity, and even elongated asteroids rarely exceed ratios of 3 or 4:1. But that was just the beginning of the enigma. The true anomaly revealed itself when scientists calculated its trajectory with ever greater precision. Oumuamua was accelerating, very slightly, but indisputably accelerating as it moved away from the sun. This violates everything we know about basic celestial mechanics. An inert object moving through space under the influence of gravity alone should decelerate as it moves away from the gravitational source, not the opposite. It was like watching a stone thrown into the air gain speed as it rises, a physical impossibility. There was only one known explanation for this behavior: the comet effect. When comets approach the sun, the heat vaporizes ices on their surface, creating jets of gas that act as natural thrusters, pushing the comet and slightly altering its trajectory. The problem is that comets produce spectacular tails and a diffuse atmosphere called a coma, formed by this same gas and dust. Oumuamua had none of this. Even the most powerful telescopes could not detect the slightest trace of outgassing, no tail, no coma, no visual evidence of cometary activity. But it was accelerating exactly like a comet. How was this possible? It was at this moment that Avi Loeb, chair of Harvard's astronomy department, proposed a hypothesis that divided the scientific community. What if Oumuamua was not a natural object? What if it was a solar sail, an extremely thin artificial structure designed to be pushed by the pressure of solar radiation, like a ship's sail pushed by the wind? A technology developed by an alien civilization, perhaps an exploratory probe sent millennia ago to investigate other star systems, now just debris eternally drifting through the stars. Loeb's proposal was met with fierce skepticism by many colleagues, some accusing him of sensationalism. After all, Occam's razor suggests we should prefer simple explanations over complex ones, natural over artificial. But Occam's razor should also not be used to dismiss inconvenient evidence. A team led by Alan Jackson and Stephen Desch proposed an ingenious alternative. Oumuamua could be made not of rock or common water ice, but of solid nitrogen ice, similar to the surface of Pluto. Nitrogen sublimates at relatively low temperatures, transforming directly from solid to gas without passing through a liquid state. Crucially, nitrogen gas is completely transparent and colorless, invisible even to our best telescopes. This would explain the acceleration without a visible tail. Nitrogen sublimating from the surface heated by the sun would act as an invisible thruster, pushing Oumuamua forward without leaving a detectable trace. The theory was elegant, but it raised its own questions. How would a nitrogen ice object survive intact for millions of years traveling through the interstellar medium? Wouldn't the nitrogen gradually sublime until nothing was left? And where in another solar system would the conditions exist to form such a large block of pure nitrogen? Perhaps in icy worlds similar to Pluto, ejected from their systems during chaotic planetary formation. The second visitor, Borisov. In August 2019, amateur astronomer Gennady Borisov discovered the second interstellar object, later named 2II Borisov in his honor. The astronomical community, still fiercely debating Oumuamua, turned their instruments toward this new visitor with renewed interest and high expectations. Would it be another enigma like Oumuamua? Another anomaly that would defy explanation? The answer was simultaneously comforting and slightly disappointing. Borisov was a perfectly ordinary comet. It displayed a clear, bright tail, a diffuse coma of gas and dust, and its behavior corresponded precisely to the comet models we know so well. Spectrographic analyses revealed familiar chemical compositions: water, carbon monoxide, cyanogen, exactly what we would expect from comets in our own solar system. Borisov was extraordinary only because it came from another star system. In all other respects, it was common. This brought a certain relief to the scientific community, a confirmation that our understanding of interstellar comets was essentially correct. But it also made Oumuamua even more intriguing by contrast. If Borisov behaved as a normal comet should, why was Oumuamua so different? The sample was still too small to draw definitive conclusions, but a troubling pattern was emerging. Of the two interstellar visitors observed so far, 50% were anomalous. The third visitor, Three-Eye Atlas. In 2025, humanity detected its third interstellar visitor, cataloged as Three-Eye Atlas. And once again, this object brought its own fascinating peculiarities. Atlas is significantly larger than its predecessors, with a nucleus estimated at up to 11 kilometers in diameter, approximately 10 times the size of Oumuamua. But what truly distinguishes Atlas is its probable origin. Analyzing its trajectory and speed, astronomers determined that it likely came from the thick disk of the Milky Way, a region populated by some of the oldest stars in our galaxy. The thick disk formed more than 7 billion years ago during the chaotic initial periods of galactic formation. If Atlas truly originated from this region, it may be a primordial fragment, a frozen piece of the galaxy's distant past, potentially older than our own solar system. Imagine, this object may have formed when the Milky Way was still young, when the first generations of massive stars were forging heavy elements in their cores and exploding as supernovae. Atlas may have witnessed, in a sense, the chemical birth of the universe that we know. This perspective transforms every interstellar object into a cosmic time capsule, carrying information about conditions and processes in star systems and epochs we can never visit directly. The most impactful revelation is not about a specific object, but about what these three visitors collectively tell us about the universe. Before 2017, interstellar objects were purely theoretical. Now we know they are real, and if we detected 3 in less than a decade with our still limited technology, how many more pass unnoticed? Computer simulations suggest that, at any given moment, there may be tens of thousands of interstellar objects crossing our solar system, most too small or too dark to detect. We are swimming in an ocean of cosmic visitors without knowing it. But here is the moment of true revelation that should make you reconsider everything. Of the 3 objects observed, only one behaved in a completely conventional way. Oumuamua remains an anomaly not fully explained with plausible but unconfirmed theories. Atlas, because of its possible extreme age and origin in the galactic thick disk, challenges our understanding of how objects survive intact for billions of years wandering through space. This means that 2/3 of our sample are, to some degree, extraordinary. If this proportion holds as we detect more objects, what does it tell us about the nature of interstellar material? Could the anomalous actually be the common, and our understanding, based only on objects from our solar system, fundamentally incomplete? There is another, even more provocative possibility. What if at least some of these objects are not natural, not necessarily Oumuamua specifically, but statistically, in a galaxy with billions of stars and potentially millions of civilizations over billions of years, how many artificial probes could be drifting through interstellar space? If only a minuscule fraction of advanced civilizations sent exploratory probes, the accumulated number over cosmic ages could be astronomical. And we, with our detection technology still in its infancy, would have no way to distinguish an ancient, inert probe from a peculiar asteroid, except for behavioral anomalies exactly like those Oumuamua presented. This is the unsettling truth. We are entering an era where we finally have the technological capacity to detect interstellar visitors, but we still do not have the capacity to fully understand them or to unequivocally distinguish between natural and artificial when the line between the two becomes sufficiently thin. Oumuamua showed us that interstellar objects can challenge our established categories, behaving in ways that do not fit perfectly into our models. Borisov reassured us by confirming that not everything coming from the stars needs to be mysterious, that our science works even beyond the borders of the solar system. Atlas reminds us of the dizzying timescale of the cosmos, that objects can wander the galaxy for ages so vast that our entire civilization is less than a blink of an eye. Collectively, these 3 visitors reveal a fundamental truth. Interstellar space is not empty, but a connected network of material exchanged between star systems, a galactic road traveled by silent witnesses of distant worlds. Each future detection brings us closer to answers to profound questions about the formation of planetary systems, the distribution of chemical elements throughout the galaxy, and perhaps, just perhaps, about whether we are truly alone. The importance of questioning conventional narratives has never been clearer. If we had simply accepted that Oumuamua was just a strange asteroid without investigating deeper, we would have missed crucial insights that now drive new areas of astronomical research. What do you think? Was Oumuamua simply an extremely rare nitrogen comet, or is there a real possibility that we detected something of artificial origin? Do you believe that 3I Atlas, with its potential age of billions of years, might hold secrets about the early galaxy? Share your theories in the comments. We want to know if you are on the side of conventional scientific explanation, or if you believe we should keep an open mind to more extraordinary possibilities. And if this dive into the mysteries of interstellar visitors has sparked your cosmic curiosity, be sure to check out our next video where we explore the mysterious radio signals from deep space that some scientists believe could be attempts at alien communication. The universe is full of enigmas waiting to be unraveled, and you are invited to every discovery on this extraordinary journey through the far reaches of the unknown.